Hi, my name is Abhinav Choudhury. I am a PhD student at the University of Maryland. My advisor is Dr. Stephanie Lansing, and we worked on this SARE research grant, scrubbing hydrogen sulfide from farm-based anaerobic digestion systems. We collaborated with Cornell University, Dr. Kurt Gooch and Tim Shelford at Cornell. And the idea behind the project was helping out farmers select what kind of hydrogen sulfide scrubbing systems they should buy based on the amount of hydrogen sulfide they are producing on their anaerobic digestion systems. So the way we were trying to figure this out was we were going to install a biogas monitoring device on the farms and look at the methane, carbon dioxide, oxygen, hydrogen sulfide concentrations on the farm. And we would also get information from the farmers about how much money they spend on scrubber maintenance, generator repairs, how many hours of generator runtime they get out of it, what is the amount of electricity they're producing, and give this information back to the farmers in the form of a biogas guide, which is currently being written, and so that farmers can make more informed decisions and when they're trying to install a new digestion system or install a new scrubbing system. So we looked at three different scrubbing systems. One is air injection or microaeration, which is basically injecting small amounts of air directly into the digester headspace. And what it does, the microbes inside the digester can remove the hydrogen sulfide and you get a cleaner biogas stream out of it. Then we had an iron oxide scrubber where the biogas passes through a column with iron oxide pellets in it, and that also can help remove the sulfur, hydrogen sulfide from the biogas stream. And the third system we were looking at was a biological scrubber, where it was an external system where the biogas again was passed through the system and microbes in the biological scrubber would remove the hydrogen sulfide and produce a cleaner biogas stream. And what we found was that some of the lower cost systems like the iron oxide or the air injection system were not as efficient, and it was difficult to manage sometimes because of the technical expertise that was required to handle these systems. The biological scrubbers were on New York farms, and they were larger operations. They had the manpower to make sure the system was running properly, and they were getting better results consistently, while the farms in Pennsylvania and Maryland were not getting good results. And what we tried to do was help them understand why their system was not working and how they could fix it. So we also gathered information about how much money they spent on their scrubbers, and and here the biological scrubbers were almost like $350,000 for one farm, almost $200,000 for another farm. While on the other hand, like these air injection systems, which consist of just an air pump, was $450, or the iron oxide scrubber cost the farmer around $500, $600. So it's cheaper, but again, it doesn't really work that well. Biological scrubbers, when they were working efficiently, would give them up to like 80 to 95% efficiency, while the other systems were not working at all, or were not removing any of the sulfur because it was not being managed properly, or it was just not set up properly. So what I'm trying to do now, based on the results from this project, is trying to look at solutions, lower cost solutions that can help out farmers and also do not require a lot of management. So what I'm looking at is using biochar and adding it directly into a digester to see if that can help reduce the hydrogen sulfide directly inside the digester without the farmer having to do anything else. Just add the digester directly into it, just add the biochar directly into the digester, and then which can help reduce hydrogen sulfide.